Hello everyone. Today we're talking about segment addition and the segment addition postulate. Now folks, some of this was touched upon a couple days ago when we were talking about distance on number line, and some of it's a little new, but it's going to be important when we go into larger shapes. We have to start proving things exist. More on that though a little later in the course. So to start things off, the segment addition postulate. If a point is between two endpoints of a segment, then the sum of the parts of the segment is equal to the whole length of that segment. I swear, folks, that is a O there. But let's see if we can fix it a little bit. ZA touchpads. All right. So, our formula. Given a line segment that's composed of points A, B, and C, with point B existing between points A and C, the full length of AC is equal to AB plus BC is equal to AC. Line segments, and line segments. Because folks, we need to always remember our proper signage. So, example 1. We want to find the value of EF. Find the value of E all the way to F. Well, EF is made up of ED plus DF. If we substitute what we know, that's 1.2 centimeters plus 1.9 centimeters is equal to our value, making the total length of EF equal to 3.1 centimeters. Example 2. Find BC. Okay. So in this problem, it tells us the full length of A to C. It tells us A to B. So we need to find the missing segment BC. So AC is equal to AB plus BC, or 13 is equal to 5 plus BC. Simplify our problems, and we should get 8 is equal to BC. Simple so far, right? Fundamental addition and subtractions. Now let's toss in some variables, like we were doing on Tuesday. We want to find X and AC. All right, so we're going to have a two-part setup here. Our AC value is equal to AB plus BC. So 2x plus 5 is equal to x plus 2x. Folks, some of you might have already figured out the problem. That's fine. Let's combine like terms. 2x plus 5 equals 3x. Subtract 2x from both sides. 5 is equal to x. So we've done part 1 of the problem. We have found what our x value is. Now, we need to take that x value and plug it in here to find our AC value. Well, 2 times 5, 10, plus 5, 15 is equal to AC. Example 4. Find the value of x and rs if s is between r and t, and rs equals 6x, st equals 12, and rt equals 72. It doesn't give us a picture, folks, so let's draw our own. Find the value of x and rs if s is between r and t. So we have a line segment that runs from r all the way to t. S is between R and T, so let's put S there-ish. We know that RS is 6x, ST is 12, and the full distance is 72. So let's set up our equation. RT is equal to RS plus ST, or 72 is equal to 6x plus 12. Well, combine like terms. That should give us 60 is equal to 6x, or simply x is equal to 10. Example 5. Point F is between G and H, given that GF is equal to 3x plus 9, FH is equal to 5x minus 2, and GH is equal to 11x plus 4. Find x, GF, FH, and GH. All right, so once more, we don't have a drawing, so we're going to make our own. Let's see, we've got F is between G and H, so here's H, here's our G, and here's our F. GF is equal to 3x plus 9, FH, 5x minus 2, and the full length here from G to H is, where'd it go? 11x plus 4. All right, so let's set up our segment addition postulate such that GH is equal to GF plus FH, which means that our 11x plus 4 is equal to 3x plus 9 plus 5x minus 2. Let's combine our like terms. We still have our 11x plus 4 on the left side, but on the right side, well, 3x plus 5x gives us 8x, and then 9 minus 2 gives us plus 7. Now let's keep combining like terms. Let's remove that 8x from both sides. We're going to subtract 8x from both sides. That's going to give us 3x on the left. We're also going to subtract 4 from both sides to get rid of that plus 4 to give us a 3 on the right side. Well, 3x equals 3. Divide both sides by 3. And we have x is equal to 1. So we've done the first part. We have found x to be 1. Now, let's use x equals 1 to figure out the rest of the segments. GF, we have 3x plus 9. Well, 3 times 1 is 3, plus 9, 12. FH, 5x minus 2. Well, 5 times 1 is 5, minus 2 is 3. 12 plus 3 gives us 15. All right, folks, now let's review some terms. Congruent. Congruent means that we have the same shape and the same size. That we use this little tilde key over our equal sign to indicate that two things are congruent. We also use our lines. We might have a line between two different things. That is to say that given congruent segments, of AB and BC, we could indicate that they're congruent by having a line going through them. By that same token, the same number of lines means they're congruent to another line segment with the same number of lines. That is to say that we could mark WY as congruent to segment XZ, such that if B, in this case, lies between A and C and lies exactly in the middle between two congruent segments, then B is the midpoint of A and C. The formula here, if B is a midpoint, then the segment before B, in this case segment AB, is equal to segment BC. And a segment bisector, folks, is an object that cuts the segment in half, making the two parts equal. So, example 6. We want to find X and Y. And folks, there was this problem on Tuesday with this. Now we're seeing it again. We know the full length of W to Y is 6 centimeters. We want to find the individual component of XY. Well, XY has this double line here. WX has this double line here, which means that segment WX is the same length as segment XY. We don't know what that length is. But in math, whenever we don't know what something is, we tend to use the variable x. So we could write this as 6 is equal to 2x. Well, simplify that down, divide both sides by 2. 3 is equal to x. So what is the length of xy, segment xy? 3 centimeters. Example 7. Find x if B is the midpoint of AC. So if point B here is the middle of AC, that means that AB is the same length as BC, which means then we can set up an equation of the two segments. Because if segment B is the midpoint, then AB and BC must be the same, which means that 2x minus 8 must be equal to x plus 17. Combine our like terms. I'm going to subtract x from both sides. X minus 8 is equal to 17. I'm going to add 8 to both sides. X is equal 25. And that, folks, is the segment addition postulate and how it pertains to the midpoint. Folks, remember, please ask me questions if you have questions yourselves over the material, and please do today's quizzes assignment. Take care.